Okay, we now do the last part of that electromagnetic induction section, which is to look at motors, generators and transformers. How do we get electricity production and then send that from a power plant to our houses, an overall picture. So to start off with the motors one, we haven't done much on this, but we've talked about the basic parts here. If you did have, say, a wire or a set of coils of wire on an axle of some sort, and we could have some sort of arrangement there where it had a metal plate there that was sort of a half circle there, be hard to draw, but like that. And they were in contact with some brushes, say a positive brush here that was connected to something and a negative brush on the other side, so that they were free to slide past on that, but they made contact with those metal parts there on the axle with the wires. What would happen? So let's say it starts off as a positive here, that one there. You'll get a current going down that wire like this, okay, and coming out to the side. Now, according to your right-hand palm rule then, if you've got a current going this way, into the board essentially, and you've got a field going across from north to south through there, which way would it go then? So you've got your current in the direction into the board, field's going across. This is going to experience a force downwards then by the right-hand palm rule. Now, if you look at the other side then, with the current coming out of the page and the field coming from left to right, this is going to be forced up. So that's going to cause a rotation or a torque there because of that turning force. So it starts to rotate around then. So after half a turn here, what's going to happen here is because of this division here between the two little semicircular plates, if you like, it could be made of copper, that'll cross over after half a turn. So the gap in between them is not as big as I've drawn there, it's a tiny gap there, which means that these are going to switch over. Because after it gets halfway around there, if you think about it, if this current was on the other side now, it'd experience a force going downwards. And what we're trying to do is actually get this to rotate in this direction. So it's no good having it get halfway around and then actually suddenly stop and try to be reverse opposite way. We want it to keep spinning fairly evenly. So therefore these two have to switch over so that the actual currents change direction, so the force changes direction and you keep getting the forces going the right way. So in other words, when it's on this position, we always want a force acting up on this side here to some degree, on that side of the coil, and always down on that side. So it's going to keep on rotating it around there. Now the size of that force will vary because of course the angle that these currents are making with the actual field is actually going to change. So that actually changes what's going to go on there in terms of size. So that's how an electric motor works. What we're interested in more in this particular one is how does a generator work. Now a generator is virtually the same arrangement as the electric motor. All we're trying to do is actually reverse the process. Instead of actually having move electricity causing magnetism and therefore motion or kinetic energy, we're going to go the other way around, turn kinetic energy into electricity by using magnetism or the change in magnetic flux. So that idea of Faraday's law there, that the induced EMF will be equal to the rate of change of magnetic flux linked to the conductor, still holds here, and the direction is still by Lenz's law. It's going to produce an EMF that induces a current that's going to oppose that magnetic flux change that produced it. Okay, so if you look at this particular one here, you basically have the same arrangement, and you can see here the slip rings that I was talking about before. One will be attached to a negative charge of a cell and the other side of a positive one. So we hit play here, you should be able to see that process of how it works as a motor. Okay, and you can see every half a turn here, it's going to switch direction of current by the positives and negatives switching, and therefore you always get a force upwards on the left in this particular diagram and a force downwards on the right.